I'm going to start with A in this video, and we'll see how it goes, and I might do A and B together. But anyway, so I have A. I want to revolve this region over here around the line y equals -1. So we're talking about this region right here. So y equals -1 is down here. So it's going to flip down like this. You know, this guy's going to go like that, and then this guy's going to go like that, right? And they're going to be connected here and here. So the one thing that I want to point out is that when I got my window here by starting with a zoom 6, and then which is zoom standard, and then adjusting a little bit. I didn't see the whole thing, so I moved around a little bit. You don't have to have this exact window, but it works well enough. I've got this in as y1 and this in as y2. So the one thing I want to point out is that I've got equations in terms of x already, and they're in my calculator. So I'm going to stick with dx, dx, because if I were to do dy, I would have to solve for x in each of these equations and work with different equations. And then if I wanted to actually integrate using my calculator, I'd have to plug them into my y equals screen. But my y's would be x's, and it would start. There would be so much to keep track of, and it would be working more than we would have to if we just stick with dx. So because we're working with our calculator, and I can just solve for stuff within here, I'm going to stick with dx. So we'll do the pencil thing. I want to do dx, so hold your pencil up in the air to try to indicate this revolution. Your pencil should be sideways. We're doing dx. That means washers. So I did a couple things there. I wrote my washer formula out, and I did the line y equals -1 so that I can measure the two, the big radius and the small radius. So, big R is from this line down to the green line. So if I do top minus bottom, I get 2x, so 2x plus 2, yep, minus a -1, which gives me 2x plus 3. So my volume equals pi integral bracket 2x plus 3 squared minus. So now I'm going to do the little r. The little r is from here, down to that green line. So the little r is going to be, what's that function? E to the x over 2 minus a -1, which just gives me e to the x over 2 plus 1. So I get minus e to the x over 2 plus 1 squared, close bracket, dx. And now, bounds. So to find our bounds, we need to find x value of blue intersection, x value of red intersection, which we'll do using the second calc intersect. I would store the first one as a, so I would let a equal, and it comes out to be -0.636, and you can write that if you want on your paper. If you're gonna, and then actually I'm gonna write from a like that on my integral, and as long as I've written this, I can then go and rewrite that like that. That's totally legit. And I'm gonna let b equal the other intersection, and I find that using my calculator as well. I do a second calc intersect, that gives me 4.955. So I'm going to write from A, undo, to B, with these two values being A and B. And I think that is done for this one. Oh, sorry, yeah, no. From there, I plug it into my calculator, and I wind up getting, I don't know, whatever it says on the key, 521.739, and I do that using fnint. If you're not sure how to do fnint, or if you want some extra little tips for how to do this stuff efficiently, go back and watch the video for number 1, the previous video on this playlist. So I'm going to go ahead now and do part B. I want to revolve around x equals 6. So x equals 6 is, I think, this right here. Is that right? Yep. And then that's going to give me shape that looks something like that. So hold your pencil up and down, side to side, whichever one it is. Try to visualize shells or washers. You should be holding it up or down. We do want to stick with dx. So I'm going to do slices like this. So I'm actually going to do this slice right here, and that's going to go with this slice. And then I'm going to do this slice, and that's going to go with this slice, right? So undo, 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 undo. So this, oops. You should sort of see my amazingly awesome, highly artistic drawing right here that represents the one layer of TP that I'm peeling away from this particular spot right here to help you visualize that we're working with shells. So I'm going to stick with this one little slice right here, and I'm going to do it in green so that I can color code my R and my H. So my radius is from this length out to here, right? So if I'm going to do right minus left. And I'm doing dx, right? So, oops, sorry. I should write, so we're doing v equals 2 pi integral r h dx. So I need to figure out my r and my h. That red line right there is, I'm going to do right minus left. So the right is x equals 7 r minus the x value that we're working with. So that's it. It's just 7 minus x. The h is equal to, well, it's the height of this green thing right here. So that green thing is the difference in those two equations. So that's this thing, oops, backwards, undo. It's this guy minus that guy. So the h is 2x plus 2 minus e to the x over 2. Plug those in. 2 pi integral, open parentheses, 7 minus x, close open, 2x plus 2 minus e to the x over 2, close. Do fn int. So I wrote it out the way it would be in the more difficult version of the TI. So I take 2 pi, that's this, fn int is the integral. I didn't rewrite all this stuff, but you have to type all that in. You could do 7 minus x in parentheses times this, so times y2 times y1 plus y1 if you want. Might be less work just to type this in. Comma variable, which is x, comma a, which is from the last one, is just stored in right here, comma b, this value, and that should come out to be, what is our answer? Equal to 292.677.